So the first part of notes that we're looking at today is going to be dealing with our number sets. So if we are talking about number sets, we're talking about groups that numbers belong to. Okay, and when we're working on number sets, we sort of have the inner group, and then as we build out, we're going to be continuing to add more numbers to it. So they don't kind of come out of the bucket. Once they're in the bucket, they stay. So the first type of numbers that we learn about from a very young age are our natural numbers. And our natural numbers are just our basic counting numbers. So you grab a block, it counts as 1. You grab another block, it counts as 2. So we have a 1, 2, anything that we can sort of count to. So whether that's 450 or 1,570,621, okay, if we can count to it, that's a natural number. And then as we get a little bit older, we say, okay, well now you don't have any blocks in your hand, so how many do you have? And we introduce the value of 0. So we're keeping all the other same numbers in here, but we are going to now add 0 to that group. So we're talking about 0, 1, 2, 3, and then continuing on that list. Okay, and then as we go a little longer, right, maybe your teacher says, okay, well, you have 5 blocks in your hand, and I want you to give me 7 blocks. And now the idea of negative numbers is introduced, and we call those our integer values. So now we're going to be adding negatives. So no fractions, no decimal yet, just our counting pieces. So the same numbers we had before, but now we're including negatives. So we can have 0, 1, 2, 3 like we had, but now we can also go the other direction and have -1, -2, -3, and continue on in our negatives. And then we get a little bit older and our teacher says, okay, now you have a pizza and it has 8 slices and you want to share it with 3 friends or something, right? And then you start learning about your fractions and decimals. Now this gets a little bit more specific because it does include fractions and it does add in decimals, but it only adds in decimals if they are repeating decimals. Okay, and that means things that we can put this like repeating bar above, like 4.6 repeating. It could be 4.232323, right, where it's 4.23 repeating. Okay, or decimals that we say terminate, decimals that end. And any fraction gets added here as well. So it still includes our integers, it still includes our whole numbers. Now we've just added in some fractions and decimals. Okay, and then you get a little bit older and you get into middle school and then you start talking about circles and the properties of circles. And your teacher now says, okay, but we have this really bizarre number that helps us find the circumference and area of a circle. And you learn about pi. And pi falls over here in its own little odd bucket. So it doesn't apply to anything over here. It's this weird number that we don't really know what to do with. Because pi is a decimal that goes on for forever. It doesn't repeat. There seems to be no pattern. It just goes on and on. Okay, so it's not in our decimal category over here, but this category over here is going to make all of our decimals that don't repeat or end. And while this does include pi, it does include some other numbers as well, and those would be things that fall into our square root category or our radical category that aren't perfect squares. So we know the square root of 25 is 5, but the square root of 7 isn't a nice, neat number. So if we use our calculator and we do the square root of 7, we get this big old messy decimal out. Okay, that's telling us that that's an irrational value. Then if we put all of these numbers together, so this is everything we've learned about at this point in time. If we put all of these numbers together, all of these are combined to make the real number set. Okay, so anything here or here makes up the real number set. So our objective is then we want to be able to look at a number and we want to decide what number set or sets it would belong to. So for example, if we look at the number 4, I kind of always tell my students to find a good starting point and then work your way out. Is number 4 a number that we could count to? Well, yes, it is. Okay, so we know that that's a natural number. But if it's a natural number, it's also still a whole number because it stayed in the bucket. It's also still an integer. I'm working my way up the list. It's still irrational. My goodness, I should have started a new line. And it's also a real, right? Because once it's in the bucket, it stays in the bucket for everything else, right? This rational box right here is still including the number 4, right? It includes 1, 2, 3. It includes all of that stuff. Okay, so -7/8. So if we start at natural numbers, is this a basic counting number? Nope, no, it's not. Is it 0? Have we added 0? Nope, it's not that. Is it negative or positive but no fractions included? Nope, it's not that. Is it a fraction or a decimal that repeats or terminates? Yes, it is a fraction. Okay, so we know that it is rational. And again, we are then going to work our way up, so it is also real. If we look at 0, 0 should be obvious because it was added to our list specifically. So here's our 0. It got added in at a whole number. And we do everything down the list. So it's a whole, an integer, a rational, and a real. Now, if we get something that's a square root, we need to check, right? Because we said some square roots are irrational. But we'll need to check and see what it actually is. And the best way to do this is to just check it in your calculator. So if we do the square root of 36, it tells us that the square root of 36 is 6. So what this is actually asking us to do is to decide where 6 goes. Well, 6 is our basic counting number, so it would be a natural, a whole, an integer, a rational, and a real. Whereas if we check and we do the square root of 52, okay, this gives us that big old long messy decimal. So those big old long messy decimals fall over here in this category. So it is irrational. But remember, irrational numbers are real numbers as well, right? This real number box encompasses everything up here. If we check -11, -11 is a negative number, so not basic counting, not including 0. Oh, now we've added negatives, so it's going to be an integer, a rational, and a real. Okay, number 7, pretty much as soon as you see pi, that just determines it for you. Unless you're multiplying pi times 0, pi is irrational. So whether we add 8 to it or divide it by 17, pi is an irrational number. All of these are going to be real, right? You'll notice on every single one, real, 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 right? All the numbers are real. And then 8.27, that's just a normal decimal. That's not one of those that goes on for forever. So since it's just a plain old decimal, that falls into our rational category over here. So this one will be rational and real.